12 through 15, we're talking about similar triangles and some similarity transformations. In number 12, they want to complete the similarity statement. Now, this is all about the order. Over here, if I'm going CER, C refers to, well, that would be the middle sized angle. E is going to be the longest. It's across from the longest side, so it's the largest. And then R is the smallest angle because it's across from the shortest side. So if I'm going to compare C, which is the middle length, I'm going to find the middle length there. It's across from B, so that has to go first. If I'm going E next, that's the big angle, so I got to find the big angle here, which is across from its longest side, so that's got to go A. And then obviously R is the smallest, across from 15. All that's left here is the shortest side with its smallest angle, Z. As far as 13 goes, the dilation, this is going to be if we do an enlargement or a reduction. So pretty much we're just plugging these points in. I'm putting that in for X and that in for Y. So the new M, which is M prime, I'm going to go 0.4 times negative 10 and 0.4 times 5. And do that same process for these other points and multiply by 0.4. For each one, you're basically just plugging in, and we're doing the same thing to X and Y. So when I plug those in, this is what it looks like. And then now you're just going to simplify. So the new coordinates of M prime are going to be negative 4, 2. For O prime, it's going to be negative 8 and 6. For P, it's going to be 0 and 10. Down to 14, where we're comparing some similar, we're trying to figure out which ones are similar. So you want to compare like the longest side of 1 to the longest side of 2, and middle side of 1 to the middle side of 2, and shortest side of each. So if I'm going to compare 1 to 2, if I'm going to go big, medium, small, I want to compare it to the 3 sides here, which is going to go big, medium, small. So I want to see if these 3 are in the same ratio. And right now, 10 over 7 is going to be 0.7. 8 over 6 is not. So these are not in the same ratio, so 1's not similar to 2. Now I can do that same process. I can compare 1 to 3, so I'm going to go like, let's go small, medium, large for triangle 1, and then let's go small, medium, large for triangle 3. Now we see here what happens is these are all going to reduce to 2 over 1, 2 over 1, and 2 over 1. So clearly 1 and 3 are similar because they're all in the same ratio. Now I could check to see if 2 and 3 are similar, but they shouldn't be. Because 1 and 2 don't match and 1 and 3 do, that means that 2 and 3 won't. Real quick, if you go small, medium, large of 2 to 3, you get 5, 6, 7. Small, medium, large for 3 goes 3, 4, 5, and yeah, this isn't going to be the same ratio. So the similarity ratio is just the scale factor. So in this case, you could write 6 to 3 or 8 to 4 or 10 to 5, but in all cases, it's going to reduce to 2 to 1. If you want to compare small to big, you could also write 1 to 2. As far as the dilation for D, if A is at negative 2, 2, B is at 1, 0, and C is at 0, negative 1, here's my triangle ABC. Not perfect, close. I want to plug in these points. I'm going to do what I did similar to number 13. Just going to plug these in, and basically what's happening is you're doubling every number. So when you double the coordinates for A, you're going to go negative 4, 4. Double the coordinates for B, you're going to go 2, 0. Double the coordinates for C, it's going to be 0, negative 2. So we should have a triangle that looks twice as big. C is at 0, negative 2. B is at 2, 0. B prime, that is. C prime. And A prime would be negative 4, 4. Connect the dots. So So we see an enlargement with a scale of 2.